Welcome CS450. We are the weather prediction group over here. We are here to talk about our data and why we chose it. So why this data? First off, this data was collected actually on campus here at BYU, Idaho from a physics professor named Brother Turcotte. He has a wide variety of different detectors, different sensors that gathered everything from UV light, rainfall, wind speed, temperature, things like that. There were no concerns in using this data, no ethical concerns. We could just go ahead and take and use it and whatever. And it makes sense, of course, to study weather predictions because no one likes their parade being rained on. No one likes to go to a picnic and have it snowing or something. So it makes sense. Our specific goals for this project is we wanted to predict the temperature of any given day given some of these parameters. The goal was to just predict it better than just saying the previous day's temperature is going to be like today was. And our goal is to get it really good accuracy within about 5 degrees of what it is, and we wanted to get it okay within 2 to 3 degrees.
So the data that we were using, we cleaned it up in R to be able to try to make the data more workable. One thing in particular that was a problem with the data is where you see timestamp on the data sheet. That originally had a time because this was broken up into 10-minute increments. And these 10-minute increments were not necessarily what we were looking for because we were just trying to predict the daily high temperatures. So what we went ahead and did is we just made some adjustments here in R effectively to group it by the day, and then to just take the highest value of the average temperature. And this is the average for a 10-minute increment, by the way. This is not the average for the day, even though this column is now technically mislabeled. What we have now is this values on the far column on the right-hand side are just the daily high temperatures for each of the given days. One problem that we found in the data was that, for example, it starts May 4th, 2017. It would go May, June, July, and then it would repeat and do May, June, July again for the same year, and it would have all the same different attributes in there as well. And all the rows were held the same values. So really the problems with that were that we were having a lot of data that was not necessarily unique and what didn't provide a different circumstance. So we used this distinct function here to try to clean those up and remove those and make it so we had data set from May 4th, 2017 up until November 22nd, 2019. That puts us at about 500 rows of data.
So we tried several different things in order to predict what the temperature would be. We used methods from neural networks, gradient boosting, random forest, and extra trees, which is just an extra random forest with some additional random elements. We also tried several different hyperparameters to fine-tune our various algorithms. We tried everything from many different layers to just a couple, and hugely varying numbers of nodes in all those layers for our neural network. We also tried various ensemble sizes all the way down from 10 all the way up to 20,000 just to see if that would help at all. And we tried other things such as the maximum amount of splits, the maximum number of features, and various depths for trees and other such parameters.
This slide shows our results. We did these results in Python, or the machine learning algorithm we ran in Python. This is the result, or this is the code that gave us the best results for the methods that we tried. This uses a gradient boosting regressor, and we played a lot with the hyperparameters inside the function. This is the combination right here you can see in line 20 of our code that gave us the best R2 score. Here we were able to get an R2 score of about between 0.85 to 0.19 or 0.91, sorry. Just to put that into perspective, one would be the hopeful R2 score that we could get. But as you can see in the right-hand side of the picture, that we would get anywhere between 49% to 61% of predictions to be within 5 degrees of the target.
So there are many things that we came across as we were going through this little journey about predicting weather that we figured would have been a lot nicer to do. Like, we could have been more productive if we just had a little bit more time. the first and foremost thing was just the obvious answer of collecting more data, because of course more information makes our progress easier. So as far as like how would we get more data, we first thing would be to go back farther, so we'd get like between 10 and 20 years of data. The positive effect of this is that then we would have a better representation from the solar effects, like solar wind or how much sun there is on a given day. And this is due to the solar cycle being around 11 years. So having around 20 years of data would account for both ends of this very well. Another really good thing to include in this more data category is to have more attributes. So a couple of things we were including were wind speed, the wind direction, how much rain you're getting, solar wind, the UV rays, and then of course how warm it was on the day, so the air temperature. But if we were to include other things such as cloud cover or humidity, we'd have a better representation of what the day is going to be like. Another good thing that we'd want to do is to learn more about the meteorological data space, to learn more like what attributes play. So just learn more about weather in Rexburg specifically, like how does the jet stream play? How does underwater reservoirs affect things? Are there any near lakes that we want to consider? And once we do that, the final thing that we had discussed doing is to attempt cross-validation. So one way to do this would just be to do a 10-fold cross-validation. So it'd be like running the test 10 times, where you do something such as like a 70% training set and a 30% test set. But you run that with different things 10 times and then compute our R-squared score that way. And so that's the gist of our project, and we're grateful for that you could watch it.